Hello everyone, today I'm gonna talk to you about full reactive apps with Asynchronous Flow and StateFlow to sync with the UI. First of all, let me introduce myself for who don't really know me. I am Raul Hernandez Lopez. I am a software engineer working in the London time zone for Twitter. If you want to follow me, that's my handle, and also you can see also my GitHub account and user just to see some Git snippets that I will show you today here in this presentation. So don't worry, you will have this later. And let's go to the agenda today. We have about 40 minutes, so I want to cover a few things. For instance, first of all, I will introduce a use case where everything will make sense to you, I hope. Then I will start speaking about the migration strategy I follow and a few things that I think are really interesting to learn. Then I will introduce very quickly some basics about calling coroutines and particular things and glitches that maybe want to be helpful for you as well to learn a little bit today. Then I will go to the longest section, that is the implementation section. And there, I hope you have a coffee already after lunch. It's going to be a bit harsh. Later on, we learn a few things that I personally think are interesting for the lessons learned along the way I had. And finally, some next steps, if there are any. So let's go to the use case. The use case is something like this. As you can see, I had a very old legacy app where you can search for some tweets. And basically here I'm trying to look for tweets with flow. I failed miserably, as you can see right there. I'm trying to, again, have this new thing and until I get tweets with flow. So basically you have here a few things. You have a view detail right now from this tweet. You have first no results because I didn't have anything saved into my database. And then when this is coming from the network, then I refresh that and I show it to the user. Something as simple as that. So imagine this is a legacy app, and actually this was a legacy app, and this was all built with RxJava. So let's see what we have into there. So now I will show you a few steps that I think are interesting for the migration strategy. And for that, we need to think in refactoring because this is a very legacy app. It's more than 3 years old, and everything is with, let's see, I don't want to spoil it just yet. Some steps to follow. First of all, we need to analyze the previous architecture. And what I had at the time is basically everything built in Java with the data layer and the repository that is managing a few data sources. That's the network and the database data source. This is connected actually with the use case. That's a business layer where you will have some business logic, like maybe transforming some data that is coming from the repository, and then you will request the info to the repository. This will return back those things, and those results are going to be also returned from the use case. This is connected actually with the model view presenter, that is the presentation layer. The model view presenter, in this case the presenter, is the responsible to connect this presentation layer with the use case. So it will execute the use case, and the use case will look those things from the repo. So basically here we have the connection amongst the presentation layer and the clean architecture side that is starting from the use case. As you can see here, we have to notice this is all with Java files. Then basically the mechanism I explained very briefly at the very beginning with this use case is that you are typing one by one a character, and the views are triggering this mechanism of one by one character. And I did something exposing basically this functionality out of the view, because for me the views should be passive. So I try to delegate those things using the delegate pattern and using something called view delegate that I will explain later on into more detail. Everything to this point is in Java. So now we need to actually check the other technologies to make sure that we cover and we have backwards compatibility requirements covered when we are building this from this point. So mechanisms we had in place. I had RxJava mostly everywhere. When I say everywhere, I mean like I have to cover this if we are migrating to a new technology like Kotlin Flows and coroutines in general. So we need to basically see where are the different connections and the pinpoints for that. For instance, I had into the clean architecture side, starting from the use case in advance, everything with RxJava. And then also I have from my view delegate, that is my hot stream when the user is typing, all starting from there as well. Cool. So let's start this migration. I will probably start changing things to Kotlin, because otherwise we cannot add any Kotlin coroutines, obviously. I will start also reproducing and extracting those results and sending those results as they were expected. That means RxJava. Same here, changing things to Kotlin, returning things with RxJava. Repository is expecting this in RxJava. It will be transformed into Kotlin as well, and then returning things with RxJava. Then the same, I started to change things here using Kotlin Flows from this side. Then I will have everything completed with Kotlin Flows as well here. Then when the use case is ready, I will start to do that also into the use case to get this and collect the things with Kotlin Flows. And then still we have some RxJava right there. So the view of Delegate should also change. And for that case, I chose to use channels as flows. Now, if we want to go even deeper and go into the UI, then probably we need to do something else, because in my case, and you're remembering the old times that where we used a clean architecture, we return the results from the use case in advance. So that means the presentation layer by means of callbacks. And this is coming from the use case to the presenter to the views. For that, maybe we can basically change those and using StateFlow. This is going to be actually more nice to have. I will explain to you why later. Then, because the presenter and the view still are in Java, maybe you need to do something else, because we need to collect the results. And for that reason, I use StateFlow handler, which is a Kotlin file, a Kotlin class, that is responsible to collect the results. So let's see some benefits that I think are interesting. For instance, reusage of existing components and elements, because I don't think right now, if you want to migrate to Kotlin Flows, you need to change your architecture. You can use something like that, like I did, or you can do something else. You don't have a final architecture you need to use 100%. You can still reuse it, but the other thing is separation of concerns. Also, talking about separation of concerns, that means layer collaboration, because imagine you are working in a big company or a big project. You probably don't want to change everything in one gap, because you are not the only one working into the project. So it's better to probably isolate things and start it from one side and making sure that you're not having breaking changes, but changing something iteratively from one side to one another, layer by layer. So let's see very quickly some basics that are interesting for us today. For instance, OpenStream. What is an OpenStream? Just in very short terms and simple, if I say, hey, today in Vulkan to you, then somebody else in the other side, in this case is Christina, in my example, she says something to me. So she tells me that she's practicing some maths because she loves it. So we can keep going into this conversation, or we can stop at this point. If we keep going and it's more than one message, this is an open stream, in simple terms. But if we don't need something like that, then it's going to be just a closed stream, one shot operation. But then, obviously, we don't need open streams for every situation. So for that, we have something in both platforms, RxJava and also Kotlin coroutines. For that, we have singles in RxJava, and also we have suspend functions in Kotlin coroutines. So basically, we return an object in a suspend function if we want to replace the single, or we have a maybe, we want to suspend, you want to change that, and we want to have a nullable object. Suspend will return then a nullable object for that particular case. And finally, the other cases where we don't care about the result that is being returned. So basically, we have a suspend function returning nothing. That means unit, because remember, nothing is actually something in Kotlin. It's not like void in Java. So we need to put unit there. Cool. Let's go to the threading very quickly. The different possibilities we have are schedulers in RxJava or dispatchers into Kotlin coroutines. We'll see later the three different variants we have there. But now let's see probably the most interesting bit that we need to understand into the basics, lifecycle. We need to handle the lifecycle with disposables in RxJava. And we have something called scopes into Kotlin coroutines. But the scopes actually have superpowers that disposables don't have. That means starter concurrency. Starter concurrency gives us a few benefits, like recursive cleanup in this case, because if we cancel, let's say, the scope that is the father of them, those processes or jobs, let's say, that are running right there, then you will basically set up the different processes under the scope. Then we'll have recursive cleanup. That means avoiding memory leaks. But now, something that I use for this sample app. Scope plus supervisor job. What does it have? It avoids other children's cancellation, and that means something like this. Process 1 or job 1, it has thrown an exception right now, but we want to keep running job 2 or process 2 and process 3. That means if we are running those things right there and we don't want to affect them with the scope plus supervisor job, you won't affect them. So that means actually that those two processes will keep running. And this is something similar that you would have with architecture components and actually the view model scope. But now let's go to the implementation. For the implementation, we have, first of all, the data sources design with the network and the database. So we are here, and what we're trying to do now is changing those singles into suspend functions, something that we learn is interesting to see right now. So for that, what I have for my network data source implementation inside there into the constructor is basically a Twitter API, because I'm returning those things with retrofit and OKCTP, and something to check if we have any connection and handling and mapping the different requests and responses. Now, for the method used into that, I passed originally into the Java function a single with a list of tweets. As this is an authenticated query, then I pass a token and then the query that the user is typing. I search for this into the Twitter API and the token being as one of the parameters, and then filtering the things just to see if this is proper or not, mapping those tweets and passing this as a single. If we want to do the same with coroutines, then I have a suspend function because this is a one-shot operation. And then I use something called ADA, that is from the Arrow library. You can use perfectly well a calling result that is equivalent. But basically here, what I am trying to do is passing in the right the good results, that's the tweets that we got from the network, or if we have any exception, just dropping this into the left side. Otherwise, in the right, we'll have those tweets. Something as simple as that. But now we need to pass, as I mentioned, a single right there, because this is what the other layer is expecting, or the repository is expecting. So by using Kotlin Routines Rx2 library, we can use this operator for this block called Rx single, and this will return this suspend function being transformed into a single, which is what we want right now before we migrate this side. Cool. Because the latest function is actually something for the database. I use the room library. And this is basically a query for some IDs that I want to return with some tweets. And then this is into a single as well. Cool. So let's see now the repository. That probably is one of the most interesting things I believe you will be keen to see today. For instance, I call it the naive approach. And I call it the naive approach because I started with a RxJava mindset. And this is probably not the best approach you can do, but it's something I did to learn. For instance, right here, starting with Kotlin Flow and RxJava into the repository. So what we have into the repo is basically the network data source that you know already. And also you have a few tables right there. So you have the table for the tweets and the table for the query, combination of the query and the tweets, as you can imagine, and a few mappers. And something called task ready that we'll see later into more detail. But let's see the implementation of this functionality we need. So we are getting those tweets that we are searching for. Basically, we subscribe into the input-output because this is an input-output operation. And then we are observing into the computation thread pool. And then we are mapping the results. We do a next for every iteration, and then we do some updates, something as simple as you can see here. Then I will do a flat map just to get things from the database when it's refreshed from the network, and I will pass the results from those IDs in order to pass an observable right there. This is the implementation from RxJava, the first one. Now I want to transform that into Kotlin Flows. So basically I change the return type to be a flow. I have map as well. This is equivalent. I have on each instead of do on next, sorry. I have the same operations right here to update. Instead of flat map, I use flat map concat and another flat map concat. So I have something equivalent returning a flow. So far, so good. Everything makes sense. And the latest function is actually a flow being returned. Cool, but now we need to make sure to understand what we are doing in Flow. First of all, Flow on operator. where you can actually make sure that you are running your operations into a dispatcher that is made for them. So this is the case for the input-output dispatcher. And flow on should be actually upstream. That means that you need to put the flow on under all the operations, below all the operations you need to affect with this particular dispatcher. That's the main difference right now with RxJava. So basically, task threading implementation has 3 different schedulers. You have one for the computation, one for the input-output, and one for the main thread of Android. I am exposing those with those methods, and those ones gonna be for me to mock into unit tests. Then we have also for the ones in coroutines, the coroutine dispatcher, and then we are exposing new methods. But here we are right now having 6 resources in memory. But then it would be very nice to actually only have 3 of them. Meanwhile, we are migrating and then transforming the other ones into the ones that are required to run in runtime. So this is actually possible. We can only use 3 resources in memory, and we can get use of the same library by using the asCoroutine dispatcher method that converts schedulers into coroutine dispatchers. Something as simple as that. We have those 3 resources, and we use them into a new method that is being exposed and being used when it's required. So good, we can use it, and it's nice. So also, because the library is very convenient, we can also have those methods already transformed into flows and then returning an observable for the next layer to be collected. That means to the use case. So as observable, we do this task for us. Now let's go to a more pro kind of approach into our experience right here. So now we are expecting to pass this as a flow, and then the use case will start collecting it. So now this is actually the imperative code. So you can see here then returning a suspend function with a list of tweets. This is into my repository. Again, imperative code, exactly the same than before, but just a kind of more readable code, as you can see here. And finally, I'm trying something right there. I am trying to return a flow into a suspend function, but do you think this is possible, really? Returning an open stream within something that's expected to be one-shot request. This is absolutely not possible. You cannot do that. But instead, you could return this with a suspend function, because suspend functions need to be running inside another suspend function or a coroutine context. Something like that. You will return this with a suspend function into room. But now, let's see other cases for flows. For instance, if you have the flow builder, you can emit all values. That means having a flow as a return type from the database. And this is a perfectly valid case if you want to return different values from the database when you are doing a poll, refreshing every 30 seconds in one other operation, and then having this open to refresh to the UI. That's perfectly valid. Also, another case is returning one single emission by having here inside this emit as a spam function. But here the thing is that probably doesn't make sense to have a flow with one emission, because this is again the same that having a suspend function returning another suspend function. So for this particular case, I wouldn't use that, but this is possible still. And then something I use for this sample app is using the flow builder and then getting 2 different emissions. One with the dirty values of the database before we refresh that from the network results coming from the network, and then emitting again when this is refreshed with the network new results. So now we can also still return as observable, because observable is still expected in the other layer. Now let's see the use case and what we have here to design it. So here we are in the use case, and now the other layers are transformed and returning the things there. And now we can start migrating also from this point. And here we have the clean architecture completed. So use case has the repository with the task threading that you already know, and the use case that is a contract using a callback at the moment. This contract, the use case, is an execute method with the execute pattern, and the query parameter right there with a callback as an input parameter as well that can be nullable. Then the cancel method, and that should be all at the moment. So the execute is initializing the callback, starting to show the spinner to the user like we are loading. And then we are starting the query. So we are searching for the tweet with the query, and we are returning some results for the unsuccess when it's right, and on error when we have a problem, and the callback will return this to the UI. But of course, we need to subscribe to the computation thread and observing into the UI Android main thread. We return a disposable that we need to dispose later on to avoid memory leaks. And then the execute method will be transformed into Kotlin. That means showing the loader, first of all, launching with a scope, the one that I mentioned earlier, so writing the scope with a UI dispatcher and a supervisor job. And inside, then we do the search tweet with the query. We are mapping those operations, so we have any, just to change that with the business logic that we need to put and fill. And the flow one, that is, again, upstream, so will affect the map operation. The catch will catch any problems we could have, and then the collect will collect the right results. Also, likewise, we have something like this one that is equivalent to the previous one, but still is a shortcut, because basically you don't have to do scope.launch, you do launching, that is equivalent, and then you have on each instead of collect. So it's quite convenient, you have the same, and also you have another added value, that is the catch is catching any problems that we could have in on each, because it's again upstream. Cool. So the scope. So the scope needs to be canceled later on, right? So we need to cancel this scope unless you have so the architecture components from Android as well. In this case, it's manually. So basically, I have to cancel this at this point and nullifying the callback as well. Now, if we need to do the same with RxJava, what we will do actually is canceling this disposable, checking if it's there, and then disposing it. Nothing else. It's quite similar to canceling a particular scope. Now that we changed that from the clean architecture, you don't need anymore this as observable to change to observable. So that can be actually a return type of flow. So far so good here as well. Now let's go to the view delegate. So what we have here, the view delegate now is expecting to trigger in this mechanism. And let's see what we had before, how we can change that into channels as flows in this case. So view delegate has the presenter, and the presenter will do something later on, but now we have also a public subject, and this public subject is the one that we are preparing for our listener. This listener is the one that we'll use for the search view, that is the native component from Android. This search view gonna need to have a query text listener, and that's the one we are creating here. And when we are doing kind of the same with flows, then we're gonna return a flow right here with the string. That's a string that the user is typing every time. And with channels, we have something like channel flow builder. This is very nice. This kind of interface, I really liked it because you could have and define the listener right there. You could add the channel inside the listener. And this one gonna be here having also more things like await clause. This is given for free because with await clause, you can actually make sure that you can nullify those listeners to avoid memory leaks. Otherwise, you have to do it manually. Also, if we see this that I showed you a moment ago, basically the channel is something I didn't instantiate, and it's because the channel flow is providing this for you. So this is very convenient. Nice. So if we want to do the same with RxJava, what we have is basically this cancel method that you need to invoke every time you want to cancel the view and the listener, and then disposing this yourself by disposing it and nullifying the disposable later on. Now, what we have into the listener is the public subject that we passed there, and the public subject will pass every query with public subject on next. We want to do the same with the thing that the block returned for us with the channel. We have a same channel, and the same channel has the operator offer. This is a synchronous operator, so we are safe to run this into the UI. So now when we are actually passing things with our Java, we use this observing into the UI, of course, and subscribing to the computation. Why the computation? Because we have the bonds, we have destination change, and we have filter that are computation operations, basically. You can filter, you want to maybe don't start your query until you have, let's say, something different than just a hash key, for instance. And then subscribing to get the different queries that we need to pass to the search tweet method. So there you will start this from the presenter, or if you have any problem, you will pass this to the other method. Likewise to that, we have with channels and the flow in concrete here, the bonds operator, the destination change, and the filter, and the flow on. And then you will catch any operation after that when we are already filtered, and we'll pass into the presenter this query by catching any problem right there and having this scope to be used. And then again, we need to cancel the scope at some point and the things from the clean architecture side. Cool, but are we done with RxJava? Actually, no, we have to do a couple of things still. So the task threading migration, you remember I had 3 resources that were schedulers. Now, probably you don't need them anymore because you don't have any more RxJava. So you can just remove those ones, creating the ones that are native to return coroutine dispatchers. So that means having those right there and returning a coroutine context into those methods. Cool, so far so good. This is migrated. And now let's go to the very interesting part of the UI, synchronous communication design. That means we are getting rid of the callbacks to make everything more seamless with calling coroutines. So StateFlow gonna be there instead. And for that, what we do is basically removing this previous use case with the callback, and we have a new parameter here for the generic type, and we'll see this in a moment. So basically, we remove the things with the callback. I'm gonna pass a new generic parameter that is tweets UI state that I will explain to you in a moment, and I introduce a new method called getStateFlow. GetStateFlow is actually returning this with a tweets UI state that could be nullable in this case. StateFlow can be also passed across different Java and Kotlin files. So it's still convenient for us because maybe we have many things in Java that we didn't have the time to migrate, really. So now the getStateFlow will pass this StateFlow right there with this parameter. And the thing is you need to instantiate the StateFlow initially with mutable StateFlow. Mutable StateFlow actually will be created with tweets UI state. Here, I create this as a nullable object, but ideally, you will have this with non-nullable. If it's nullable, like this case, you will initialize this to null, and then you will expose the mutable StateFlow to the different cell holders into a method called, in this case, getStateFlow, or whatever you want to call it, by passing this as a StateFlow. The thing is, StateFlow, apart from being an interface that is read-only or immutable, has a few benefits, like this thing that been changed is by default. That means you cannot apply it because it's already there, and you can use it for free because it's there. That means that only when you have a different state, it will change and it will have an effect. For instance, if we have this tweets UI state, is basically when you pass the tweets with the list results UI state inside. This is in the data class, as you can see here is read only because the tweets are val. Then when you have an error, the same with the message to show to the user. Then empty UI state, when you want to have the empty state, like we don't have with this search, we didn't find any query for this particular thing that you look for. Or let's say when you are loading, you want to show the spinner first of all. So you need basically to cover different UI states. That's really important. Now, if we are migrating, we are getting rid of the different callbacks. So we remove the callback right here. We pass the loading UI state first to the value. So that's basically the property function for the value or set value. Then you pass the loading UI state first of all. And then when we are searching for the tweets and the query and we are returning those tweets, we have to analyze what we have here. I check if this is empty, this collectible list of tweets. If it's empty, then I pass the empty UI state. But if it's not empty, I will pass the list results UI state with the tweets embedded into that data class. And then it's going to be passed by means of this dot value, as simple as that. Then the catch going to be passing the error UI state with any message that comes right there. And we'll obviously have this into our scope. Now we need to collect different results. And for that, we are into the view that is still in Java. So we need a frame for this Java to be collecting those states. Now here into the placenta, we have the use case, and the use case will be canceled at some point. So we have those methods right there. Then starting to do that from the placenta, we're going to get rid of the different things we have for the callbacks into the placenta. We'll execute the query, we'll remove the callback, and we'll expose this to the different shareholders by passing the getStateFlow. Right there, passing also to the view delegate that I had, passing that from the placenta to the other shareholders. That means having this other method. And this getStateFlow going to be used right now. For instance, here, I'm going to initialize into my view delegate the search view, going to be applying that. And also, I will pass the reference to the fragment or the activity or whatever you are using right there. I will apply those things, and I will pass this getStateFlow to initialize that. So let's see what we have there. So this is, let's say, the fragment, for instance, and we have the view delegate injected, and also the StateFlow handler injected. So we are installing the StateFlow, having the reference from this view into that StateFlow to collect things. And we are initializing with this method called process StateFlow collection. StateFlow, again, can be passed across different Java and Kotlin files. And now into that StateFlow handler, what we have is basically a reference to this view that we have injected into the init, and then the StateFlow. So the StateFlow that is inside there, gonna be, first of all, filter. Again, this is because it's a nullable StateFlow. If it will be not nullable, then you don't need to do this filter right here. And then on each, that's gonna basically do the handling for those states and will pass StateFlow as this is expected to be. Then we'll collect that with a scope. This is very important right there. And then we'll start the things from the fragment. That means we are passing these tweets UI state. We have different StateFlow with the different states that we already consider into the seal class. By loading the UI state, we'll do some operations for the show loading, or we'll do some operations to show some results with the StateFlow. And maybe we do some empty state. There is something that we don't want to show because we don't have anything to pass, or show error or something else by the default. So we are actually passing the StateFlow with the tweets UI state right there. Cool. So now we have StateFlow handler, and what we need to do is starting to cancel this when we are closing the screen. So basically, cancellation of the scope is required. Also, we need to make sure that we don't have a view into that, otherwise you're going to have a big memory leak right there. And then obviously this, when we are closing the activity on the fragment or something like that, we need to cancel the different things that we have inside, destroying the views and canceling the different scopes, unless you have something that is self-managed, that like the lifecycle scope that is doing this for you. And with that, we have something that is full reactive with flow done. Cool. So let's see now some lessons learned that I think is the most interesting bit for you, I guess. For instance, exchangeable. When I say exchangeable, is the fact that when you are starting to do this migration, you can mostly start from one point where you have RxJava. You can try to convince your team by saying like you're gonna change some things and you are not going to have any breaking changes because you are responsible for one of the layers. And by that I mean like you're gonna make sure that the next layer is prepared for those inputs to be passed as they were expected. In this case, if you migrate this into suspend functions, this can be returned as a single or an observable or whatever you want to do. And it can be the opposite direction as well. If you want to do this from another side, that means from the view to the deepest layers, you can also start from that point and you can change that with that library. And it gives you a lot of flexibility as well. So this is very convenient. If you want to commit your team that this is there for you to be migrated because you prefer to do that with color coroutines for the reasons you have. Nice. Also, we have sort of concurrency that is super cool to have. It gives us the ability to have self-completion for the streams, as well as the fact that it's going to be canceling all the different things inside this scope. And you don't have to do it in every layer because if you remember with RxJava, we have composite disposable that basically finishes a few set of disposables. But if you have this in different layers, you have to do it in every layer manually yourself. So static concurrency is super cool if you have it, and it gives you a few benefits as well. But the fact is that static concurrency is gone when you are using observables and dispatches simultaneously. That means, in my case, in the thing that I showed you, in one of the things, I was passing this as an observable, but this was a suspend function. But these things that we have here, with suspend functions returning a single, doesn't have the benefit of the suspend functions right here with a coroutine context, because what you need to handle is actually this side that is having the RxJava. So you need to actually dispose it. So you don't have any advantages here of a static concurrency. And this is what's going to happen to you when you have migrations in one of the sides. It's inconvenient, but it is what it is. Also, imperative versus declarative programming. When always we see this meme and we think like, it doesn't work, I don't know why, or it works, but why does it work? And the fact is that this can be happening to you as it happened to me, because when you program those things and you got used to Java, you have this declarative mindset in mind, like, yes, I'm gonna do filter, I'm gonna do mapping, I'm gonna do again this and that. And then you go to suspend functions and everything is super readable, of course, but it's imperative code. So now you have to change slightly your mindset until you arrive to the side of collecting those things, and then you can again do filter and those kind of things into flows. So this is going to be a bit of mind blowing, and you need to balance what you need to use at any time. So basically, in a nutshell, those pros and cons I found myself. RxJava is declarative 100%. And again, coroutines, suspend functions are imperative, but flows in general are declarative. So you have to balance those things that I already mentioned. Then for RxJava, the manual cycle handling, when you need to dispose them yourself, unless you have another library that does it for you, because there are more than one actually. Or maybe you have coroutines and flows, and then you have static concurrency that is super convenient and going to help us a lot. And then finally, if you are doing this migration and you have Java and Kotlin, RxJava, it works quite well. You wouldn't have probably many problems unless you have some wildcards that maybe you need some more handling. For that reason, you will need to use maybe Rx Kotlin, let's say. Then, however, if you have a greenfield project, coroutines and flows is perfect for calling and friends. So it's the thing you're going to need and the right tool for the right thing in a new project, in my opinion. So next steps, I will say waiting for stable flow APIs, not having deprecated, but this is what I told in previous talks. However, I will say no need to wait for stable flow APIs because flow now is stable, StateFlow is stable, calling coroutines with suspend functions are stable. You have a few things that are not yet stable, I think, but they're gonna get very quickly there. And that's basically all. So to wrap that, you have a few things that I will share later on in my slides. So no worries, you will see a few things. You have more to read. Articles I wrote previously. So no worries, those are done for you. And if you lost any into those details at some point, this is gonna be there for you. And special thanks to Manuel Vivo, who removed those slides in the first and the second iteration, that is this one. Thank you to you for being here today and waiting until the end of the talk. And yes, if you have any questions, I am more than happy to answer them for you.
Right, Raul, thank you so much for the talk, and thank you for giving us such a deep insight into the how it works under the hood. So it's really great to see a lot of code, a lot of like what do you need to like really physically do when you migrate and when you change around.
Thank
But
you.
it was like a little overwhelming to get all the code. It's a little hard to digest, and I'm sure that some of the people following the stream had a similar experience. So maybe if you could briefly summarize like what is the main things that you need to do when you migrate, like what is the main difference in the code, where do you have to like really dig your hands in the most.
Sure. Of course, the TLDR is like, this is an advanced talk. So if you didn't have any insights, obviously it's overwhelming 100% with you. So you need to read a few things. It's not like it's super easy, straightforward, or anything like that. You need to have some practice, get used to the different things, and understanding, first of all, the coroutine context and those kind of things that are super different from RxJava. But there is not other way than practicing. That's my particular take for that. I will say, like, if you use RxJava, it shouldn't be too difficult to change into Kotlin Flows because in a sense it's quite similar. But then if you want to do some suspend functions, it's slightly different because then you have to do and write this imperative code. So basically it just requires a bit of practice. When your mind clicks, then you will understand that better. But also I think that's why I also introduced a few things into there and those comparisons, because otherwise you couldn't see the differences yourself without code. So this is what it is, because we don't have any other way than just reading code and trying to practice ourselves.
Right, yeah, totally. And I really like that also during your talk, and also especially in your answer, you made like a nice bridge to the other talks as well. Like when you said just now that like start experimenting with something small, that really reminded me of the talk that we had before the break of Sarah, who said like this is the way to learn, like that kind of mindset. And then also the point about just like you have this big overwhelming legacy system, you want to convince your team to migrate, and of course they will see it as a big costly risk, especially if they don't have experience with it, but that you can just like take a small tiny part and just rework that and showcase it and try it out as a team as well if it works for you. So
Mhm.
it's something that to the beginning Carlos also mentioned. I think that's such a smart way to design a framework or a language or technology or something that is within the ecosystem. If you want to change people and their behavior, to just make it very easy and low risk.
Mhm. Yeah, yeah, of course. And also, I think it's very difficult to convince teams. I wouldn't say this is something we have in place in our company, for instance. It's something we are wondering at some point, but I suppose it's easier when you have a small team to convince for those kind of things. And also because now it's stable, we're in a better position. The first time I started with this approach, I think it was last year in April, and I did the first talk about this topic, and I was advancing. And then we had at some point state flows that we didn't have at the time. This also helps because now you have a very nice interconnection of different layers, and now you can get rid of those callbacks that are not probably the best pattern to follow. And yeah, I think we are now in a much better position than 1 year ago to try to have a full pipeline with a Kotlin coroutines, StateFlow flows, and so on.
Hmm. Okay, what would you think like would be the biggest selling point if I would have to convince my team to make the switch or to try it out? Where do you see the biggest advantage
So
or
the
the
biggest
cool
advantage
feature?
is mainly, I think, getting rid of a super expensive and heavy library like RxJava, because it's an excellent framework, and Kotlin coroutines, despite it's not the Kotlin standard library, is still into the language. It's just a layer in the top of the Kotlin standard library. That means that is quite ready for our code. And because Kotlin coroutine is going to be inside many new components on Android in this case, and even more in Kotlin multi-platform world in the next months to come, I guess. It's also so inconvenient because at some point we're gonna have for sure some UI components using calling coroutines. You wouldn't know, you will have them, and you're gonna have them anyways. So you think like, hey, I don't want another library because calling coroutines is a new library in the top of calling standard library. You are lying to yourself because this is gonna be there already with new components of UI. So you don't have now this reason to say no to that.
So basically, it's one step towards modern architectures and to modernize your code that eventually you have to do anyways. And now's a good time to like gradually grow into it and get rid
Yeah,
of some of
I
the
think so.
technical debt.
Mhm. Yes.
Cool. Yeah. So any other questions from the audience? I haven't seen any yet, but please put them in the chat. Ask a question. And while we wait on the question, I pretty much gonna recycle the question that I had earlier because you had mentioned the same. You talked about the different mindset between the imperative and the declarative world, and like for the migration, then people have to also think differently from the Java world, the imperative towards a much more declarative way. So, what do you think the biggest challenge or the biggest change that you have to have in your mind or in your concept and your paradigms would be?
So I guess going back to the same reasons I gave, it's just the fact that in a declarative mindset, you are more looking into what you need to do rather than how you need to do it. But when you do imperative, you actually need to clarify those details. That means that you need to explicitly say what you are doing and how you're gonna do it. So basically, that's the main difference. It's something that we're gonna need to be get used in some ways, and also change our mind in any other ways. Because if we think in Jetpack Compose, for instance, then we have a declarative mindset, which is slightly different. That suspend functions that is imperative code. So actually, I think we as developers, either Android or multi-platform in the future, we're gonna need to make sure that we understand both of the paradigms, because we got very used to declarative in some ways and imperative in another ways. But now we're gonna need to combine them 100%. So I think it's important to play with those things because in one of the ways or one another, we need to use them in the future. Compose is something that is coming. I think the community is so pushing for that because it's so nice. And this also helps us to change our mind and understand better imperative and declarative. So I think it's also important for us.
Mm-hmm. Yeah, so you think it's just a matter of time, basically, that the switch is done and that the community jumps on board, or do you think that there's still a place for RxJava in the long run, or will it be entirely done with?
I think yes, because when you have a big code base, it's very difficult to migrate everything. And there are not enough reasons to just change right now from RxJava to Kotlin coroutines. But if you think in advantages, I think there are good reasons if you want to plan in advance. And at least maybe to change more into states if we want to go into compose, because the declarative way is unidirectional data flow. So you can do this with RxJava as well. So, it's more like a matter of an equilibrium and thinking what you need to balance for your team and what is important for you in the next future. So I suppose those kind of things should be something that the team should think more about, thinking in advance for a few quarters from now. So it's going to be actually something to think about for sure.
Mm-hmm. Okay, so it's of course the migration is expensive and it will take a while, but like for a new project, there would be no reason to use RxJava.
I think so, yeah, exactly that. Hmm.
Mhm.
I agree.
Okay, so now devil's advocate question. So there are no weaknesses at all, and it's just awesome. The flow.
Weaknesses, I will say there are for sure. There should be also in RxJava. I suppose to do things like we have in RxJava, maybe we need a few more operators, and at least we have many right now, but I suppose more need to come. But now with ShareFlow and StateFlow, we have a few more things we didn't have in the past that came last year. So mostly the things you could do with RxJava, you can right now do them with Flow. But yeah, I think everything gonna be very seamless compared that we have before. The thing is, RxJava is a super complex and big library, which gives you a lot of possibilities, but at the same time, maybe you don't need all those possibilities. So you have a small project or you are starting a new one, maybe you don't need as many possibilities as you could have. So this is also something to think about. Yeah.
Mm-hmm. Okay. Well, thank you for the talk and thank you for answering all the questions. There's still no question in the chat, so people are a little shy. So write us, shy people, send us an email. We will forward it. And yeah, it's almost the end of the day, and I still haven't figured out the mirror thing. It's just you're just so used to like having the mirror be like this, and then it's flipped all the way. So yeah, still a lot to learn from my part too. But thank you so much for being here. Thank you for the interesting talk, and enjoy the rest of the day.
Thank you. You too. See you.
Thank you.